Writing terms of a sequence given the general or the end term. So this is our lesson for today for Math 10. Many situations in the field of science and mathematics involve numbers arranged in definite order or sequence which are related to each other, such as minutes in an hour, successive powers of 10, and many others. A sequence or a progression is a set of numbers written in succession. Each number of a sequence is called a term. The first number is called the first term, followed by the second term, the third term, and so on. For example, this one. For number 1, we have 1, 4, 9, 16, and 25. So this is our sequence. And our first term is 1. Second term is 4. What is our third term? That is 9. How about the fourth term? 16. And the fifth term is 25. So this is our sequence. This is an example of a sequence. We have a pattern here. So what is our pattern? Or what is the rule for this sequence? So the rule is squaring counting numbers from 1 to 5. Why is it so? So try to look at here. First term is 1. If we will square 1, that's 1. Second term. So that's 2. Squaring of 2, that's 4. Third term. 3 squared, that's 9. Fourth term, that's 4 squared, 16. And the fifth term, so square of 5, that is 25. So simply, our rule for this sequence is squaring counting numbers from 1 to 5. How about second example? Our terms are 2, 4, 6, 8, and 10. So take note of 2. What did we do to 2 to get 4? What did we do to 4 to get 6? And so on. So what do you think is the pattern or rule for this sequence? So we have every term after the first is obtained by adding 2 to the numbers preceding it. Let's try to find out if this rule is really correct. So first term is 2. Add 2, we have 4. 4 added by 2, we have 6. 6 added by 2, we have 8. 8 added by 2, we have 10. Therefore, our rule is correct. Every term after the first is obtained by adding 2 to the numbers preceding it. So these are examples of sequences. It follows a certain rule or pattern. Okay, how about this one? By following the pattern, write the next 3 terms in the sequence below. So we are asked to complete the given sequences by adding next 3 terms. For first example, we have 1, 8, 27, 64. Okay, first term is 1, followed by 8. Next is 27, then 64. What do you think is the rule or the pattern for this sequence? And what do you think are the next 3 terms? Try to look at here. From 1, it becomes 8, then it becomes 27, and it becomes 64. So what do you think are the next 2 terms? So we have 125, 216, 343. So what therefore is the pattern or the rule for this sequence? So we simply raise a certain counting number to 3. So you have 1 to the power of 3, that is 1. 2 to the power of 3, 8. 3 to the power of 3, 27. 4 to the power of 3, 64. 5 to the power of 3, that's 125. 6 to the power of 3, that's 216. And 7 to the power of 3, that's 343. Therefore, the rule or the pattern for this particular sequence is raising the counting numbers from 1 up to 7 to the power of 3. Okay, how about the second example? 1, 3, 5, 7. What do you think are the next 3 terms? Look at the pattern for this sequence. What did we do to 1 to get 3? What did we do to 3 to get 5? And so on. So what do you think are the next 3 terms? Okay, therefore the next 3 terms are 9, 11, and 13. Therefore, what is the pattern? we simply add 2 to the preceding term to get the next term. Let's see. 1 plus 2, that's 3. 3 plus 2, that's 5. 5 plus 2, that's 7. 7 plus 2, that's 9. 9 plus 2, 11. And 11 plus 2 is 13. So simply our pattern for this sequence is adding 2 to the preceding term to get the next term. How about example number 3? We have negative 3, negative 6, negative 9. What do you think is the rule? Look for the pattern. What happened to negative 3? Or what did we do to negative 3 to get negative 6? And what did we do to negative 6 to get negative 9? So what do you think are the next three terms? It's negative 12, negative 15, and negative 18. So what do you think is the pattern? That is simply adding the preceding term by negative 3 to get the next term. Let's try. Negative 3 plus negative 3, that is negative 6. Negative 6 plus negative 3, it's negative 9. Negative 9 plus negative 3, it's negative 12. Negative 12 plus negative 3, that's negative 15. And negative 15 plus negative 3, and that's negative 18. So again, the rule is simply adding negative 3 to the preceding term to get the next term. Last example for number 4. Y to the power of 2, y to the power of 4, and y to the power of 6. What pattern have you observed for this particular sequence? And what are the next three terms? So look at the exponents. We have 2, 4, 6. So what do you think is the next exponent? Let's try to find out. Okay, so therefore, our next three terms are y to the power of 8, y to the power of 10, and y to the power of 12. What did we do to the exponents? We simply add 2. 2 plus 2, we have 4. 4 plus 2, that's 6. 6 plus 2, that's 8. 8 plus 2 equals 10. 10 plus 2 equals 6. 10 plus 2 equals 12. Or simply, we multiply each term by y to the power of 2. So our rule for this fourth example is multiplying each preceding term by y to the power of 2 to get the next term. Got it? Okay. To avoid misunderstanding about ordering, the nth term or the a sub n, this will be read as nth term, of a sequence is designated by an algebraic formula. The n subscript is understood to start from 1, then 2, and 3, and so on, unless otherwise stated. Example number 1. Write the first 4 terms of the sequence with this general term. N term is equal to n plus 1. So we are given with the general term or the rule or the n term, and we are asked to find out the first 4 terms. How to solve it? We have solution. First term, that is denoted by a sub 1 since it's first term. So our n here will be replaced with 1 since it's first term. Our n here again will be replaced with 1. And then copy plus 1. So 1 plus 1, that is 2. Therefore, our first term is 2. Now, to get for the second term, now take note, it's second term now. So our n will become 2 since we are talking about second term. So we have n will be replaced with 2. And our n here will be replaced with 2. So 2 plus our constant 1 here. So 2 plus 1, and that is 3. Therefore, our third term is 3. Now, for the third, again, our second term is 3. Now, for the third term, since it's third term, therefore, our n will become 3. And this n here will be replaced with 3. Okay, so 3 plus 1, and that is 4. So therefore, our third term is 4. And our fourth term, since it's fourth term, so our n here will be replaced with 4. So this n will be substituted by 4. So 4 plus 1, and that is 5. So therefore, our first 4 terms are 2, 3, 4, and 5. So these are the 4 terms of our sequence following this general term or the n term. A sub n or n term is equal to n plus 1. Example number 2. Write the first 5 terms of the sequence whose n term is this one. N term is equal to 2 times n squared. Take note, we are going to write the first 5 terms. Solution. For the first term, since it's first term, so we will replace n with 1. This n here will be replaced with 1. So that is 1 squared, that's 1 times 2, and that is 2. So our first term is 2. For the second term, since it's second term, we will replace n with 2. Again, this n will be replaced with 2 since we are talking about second term. So we have 2 squared, that's 4, times 2, and that is 8. Okay, so our second term is 8. Now, for the third term, again, this is our n term. So for the third term, since it's third term, our n now will become 3. Okay? And this n here will be replaced with 3. So 3 raised to the power of 2, or 3 squared, that's 9, times 2, that is 18. So our third term is 18. So take note, you are going to simplify this one first, 3 to the power of 2. Next is multiply the result of this with 2. That's the rule. Raise this one to the power of 2. Next is multiply it with 2. So again, 3 squared, that's 9 times 2. And that is 18. Next, we have fourth term. Since it's fourth term, so we will replace n with 4. This n here will become 4 for the fourth term. So again, we have 4 squared, 16. That's 4 times 4, so it's 16. Times 2, and that is 32. So our fourth term is 32. Again, square 4 first before multiplying it with 2. So that's 4 squared, 16, times 2, that's 32. And for the last term, that's fifth term. Since it's fifth term, so our n now will become 5. So replaced n with 5. This another n will be replaced with 5. So square this 5 first before multiplying it with 2. So 5 squared, that's 5 times 5, that's 25. Times 2, and that is 50. So this is our fifth term. Therefore, our first 5 terms of the sequence are 2, 8, 18, 32, and 50. So these are the first 5 terms of our sequence using our n term, which is n term is equal to 2 times n squared. Got it? Okay, how about for this third example? Write the first terms of the sequence, first 5 terms of the sequence whose n term is given by this one. N term is equal to 3 times n minus 1, or thrice n minus 1. So take note of this n term. We will be looking for the first 5 terms of the sequence using this general term or the n term. So solution. For the first term again, since it's first term, we will replace n with 1. This n here will be replaced with 1. So that is 3, copy 3, and then copy minus 1. So we have 3 times 1, that's 3. Minus 1, that is 2. So therefore, our first term is 2. Okay, for the second term, again, that is our nth term. So take note of our nth term. That's the rule or the general term of our sequence. So to look for the second term, since it's second term, we will replace n with 2. So this n here will be replaced with 2. Copy 3 and then copy this minus 1. So multiply first before subtracting it by 1. Take note of that. So 3 times 2, that is 6. Minus 1, that is 5. So our second term is 5. How about for the third term? Again, it's third term. So our n will become 3. This n here will be replaced with 3. So multiply first before subtracting. So we have 3 times 3, that is 9. Minus 1, and that is 8. So this is our third term. For the fourth term, since it's fourth term, so our n here will be replaced with 4. So this n here will become 4. So 3 times 4, that is 12. Minus 1, and that is 11. For the fifth term, so again, it's fifth term. So our n here, this 2n here will become 5. So replace n with 5. This n here will be replaced with 5. So we have 3 times 5, that's 15. Minus 1, that is 14. So that's our fifth term. Therefore, the first 5 terms of our sequence using this nth term are 2, 5, 8, 11, and 14. So these are the first 5 terms using this nth term. Nth term is equal to 3 times n or thrice n minus 1. So in looking for the first 4 terms or the first 5 terms of a particular sequence, given the general term, we will simply substitute n with the number or ordinality of the term that we are looking for. Then simplify. We come up with the desired term. Okay? Hope you learned something from this. Thank you, and this is Teacher Con.